Hello and welcome to our sixth lecture in the Jabrah reinforcement learning series. And in this lecture, we're just going to finish up on the policy iteration algorithm, our first reinforcement learning algorithm that we've learned. And just as a reminder, I just wanted to let you know that the in-depth material of what I'm covering here, you can find it in Richard Sutton's book, uh, Intro to an Introduction to Reinforcement Learning, right? So if you just search for this, you should be able to find it. But I think the name was Reinforcement Learning and Introduction or something like that. So this is really a good book, and it has like most of the things that we're covering here, maybe even in more detail actually. So now that we've covered pretty much the basic idea behind policy evaluation and policy improvement, in the two previous lectures, where we just say that policy evaluation is when you are given a policy and you're trying to evaluate how good that policy is by computing the value function for that policy. And policy improvement is basically you try to improve the policy with respect to the current computed value function. Um, so first of all, before like going through the pseudocode of the algorithm, the general the policy iteration algorithm, I want to talk about the concept of uh, generalized policy iteration that's covered in this book that I just mentioned here. The idea of generalized policy iteration. So most reinforcement learning algorithms that we'll go through, they follow or they fall rather under this branch of generalized policy iteration, because what we have is two like interacting processes, right? So what are we doing in policy evaluation? Let's think about it. Like in policy evaluation, I'll just denote this as PE, right? So we're trying to make the value function consistent with respect to the current policy, right? So we're trying to make the value function consistent with respect to the current policy. And so someone gives us a policy and we try to find a value function under that policy. And on the other hand, we have policy improvement. And what are we doing here? So in the gist of policy improvement, we're trying to make the policy greedy, right? With respect to the current value. Sorry for the misspelling here, but you get the general idea, right? So that's the idea. So with policy evaluation, we're making the value function consistent with the policy, and policy improvement, we're making the policy greedy with respect to the current value function. So these two processes of evaluation and improvement are interacting together. So what we have is sort of a diagram that looks like this, where this is of value function, v is equals to v pi, and we have another diagram, another line here for this is our what you call this, we have our policy that we're trying to make greedy with respect to the value function, right? So our policy is equals to greedy with respect to oh sorry, I miswrote that, with respect to the value function. That's the idea. So we start with some random policy pi, right? And we initialize our v's to some value, right? So what we're trying to do is compute the value function for that policy. And once we have the value function for this policy, the next thing is to try to make this value function to find a policy that is greedy, right, with respect to this value function. And once we find this policy that's greedy with respect to this value function, next thing we need to do is compute the value function for that new policy, and so forth. So these processes interact together until finally we have an optimal policy, which we denote as P star. This is the best policy we could have under these conditions, and the optimal value function, which we denote as V star, right? Well, this is just notation for optimality, right? So what's happening in policy iteration actually is something that is quite similar to this. Actually, I can say it is this, because we start with a random policy. Someone gives you a random policy like pi 0, right? Let me use a different color. So someone gives you a random policy pi 0. So what's the first thing you need to do? You need to evaluate this policy, which we'll denote with E, and then you'll have a value function for that policy, which we denote as v pi 0. Then once you have v pi 0, you want to improve, or rather make this policy greedy with respect to this value function, right? Which is what we call policy improvement. And after doing that, we end up with a new policy pi 1. So we evaluate this policy, right? And we get v pi 1, and we improve this policy, right? And from there we get pi 2, right? And we evaluate again, and it goes on and on until we reach a point of improvement where we get the optimal policy P star, right? The convergence area. And after evaluating, we'll get the optimal value function V star. So this is the general idea behind the policy iteration algorithm. We're just doing the steps one at a time, right? So what does this look like in pseudocode? So let's actually go through the algorithm. Okay. So let's start with the algorithm. So the first step is the initialization step, right? So we've got initialization, right? So basically what we have is vs, our initial value function, right? It's just an element of r, and we can initialize this to be maybe just a vector of zeros or something. And our initial policy, pi s, right? We initialize our initial policy. We can start maybe with a random policy, it doesn't matter, right? That's an element of the action space, right? So that is for all s is an element of s, right? If you remember the notation. So first step is policy evaluation, right? So we've already gone through this algorithm, so I'm just going to speed it up. So policy evaluation, if you remember, we just I'm gonna split this algorithm in split this part into two so that it doesn't confuse. So we repeat the following. If you remember, we start with a delta, we assign it to 0, and then for each, so I'm not going to explain exactly what's happening here because I've already explained it in a previous video. So if you really want to go through how this algorithm works, you can watch lecture 4, which was on policy evaluation. So for each s is an element of s, we are going to assign some v to that, right? And then vs is actually gonna be summation over s prime comma r of p s prime comma r given s comma pi s, right? So this is and then we multiply this by r plus gamma times v of s prime, right? So I have limited myself here. Let me just clear this line and maybe extend it a bit. Right, let's extend it to here. Okay, so that's v of s prime, right? But don't forget that this can be a probability distribution as well, in which case, if that's the case, we also need to add the term here. Make sure you're careful about this. In case the action space is also a probability distribution, you might need this term here. So just go to the previous lecture and you understand what that is. And finally, well, not finally, but we update our delta to be the maximum between the current delta and v minus vs, right? And this will happen until, right, delta is less than theta some small number, some small positive number actually. So yes, I just rushed through this algorithm because you should already know how it works from the previous video. So this is policy evaluation, and now the policy improvement part, I guess. From the previous lecture, we didn't write the pseudocode for this algorithm, but we have the formula. So if you remember from the formula, so what we do actually is we define a variable that we'll call policy stable, right? Boolean. Policy stable, and we set it to true, right? We assume the policy is stable at first, and for each s is an element, for each s is an element of s, what do we do? For each s, we're gonna say that the old action, right, we're gonna assign it to pi s, right? This is our old action. And what's our new action? Well, this is actually coming from our formula. So we update the policy at the current state to be equal to, rather we assign it to the argmax over all possible actions, right, of this term, summation over s prime comma r of p s prime given s comma a. If you remember this, there can be an r there, but I'm just going to ignore it here. Multiplied by r plus gamma v pi prime of s, v of s prime, v of s prime. So this is essentially what we update our new policy to be, right? This is how we're making the policy greedy, right? By computing this argmax, we're making the policy greedy. Then after that, we're gonna make a check if pi s, right, is not equal to old action, right? Right. If after computing this argmax we realize that it's not the same as the old action, that means the policy is not yet stable. So we assign the Boolean policy stable to false. Right. We assign it to the value false. Right. And so finally, after going through the state, so if the policy is stable, then stop, you're done. The algorithm is converged, right? You have found the optimal policy, right? You have found the optimal policy, else go to step 2, right? Go to step 2. So that's basically in a nutshell how this algorithm works. And so you start with the policy evaluation, which you already know. The policy improvement is just assuming that the policy is stable. Then for each state, we try to make it greedy and see that has there been a change in the new policy compared to the old policy. So if there has been a change, that means that we're not yet stable. We should use our new policy, which is better than our old policy. And after doing that, we are supposed to find the value function with respect to that new policy, and then we're gonna come back and repeat the same process, right, until we reach a state whereby the policy is stable. And if the policy is stable, then we can stop and we find the alternate values. So this is in a nutshell the pseudocode and everything, but in the next lecture we're actually gonna put it into practice as we start with our first programming exercise where we implement this policy iteration algorithm in the environment that we described before. Let's see if I have it here. This environment here, the cat trying. So basically we'll be trying to find like the optimal path, right, to this point. That's what we'll be trying to do and trying to avoid these areas, right? So I'll describe this more in the next lecture, and I hope this video has given you a better feel or better idea of what policy evaluation is, what policy improvement is, and how they come together to bring and give us the policy iteration algorithm. Thank you for your time.